Thank you, everyone. Can you hear me? Yeah, I think. It's great to be here. We had a lovely evening yesterday, so thanks a lot to the organizers for such a wonderful time, and thanks a lot to all of you for being here on the first session in the day after the dinner. I'm not a Node user myself, so I've been enjoying this meeting very much because I've been learning quite a lot about the Node community, about the wide range of science topics that the Node community is doing with the telescope. And the purpose of my talk today is give you the opposite perspective, also the perspective from the IAC side. And some of you, I mean, many of you, of course, know the IAC, but perhaps you don't know the latest numbers on how many people we are, the kind of science we do, and the kind of use we've been doing with the telescope. And this is the purpose of my presentation. Just to give you a little historical perspective, I'll be very, very brief. There we go. It's been a long journey. It's been more than 30 years already working together. Inauguration happens somewhere in '89, but in fact, collaborations with the Nordic countries started actually before that, a few years before that. And it was a slow start because it took like 10 years to produce the first 100 papers. And the first 100 IAC papers, okay, papers with the IAC members using the Node telescope. So not too bad, but not too fast. Obviously, when you start running a telescope, it takes time, and the community, the IAC community, as you will see in a minute, it was less than half of what it is now. So, you know, the slow start was kind of a given. Later on, moving on, you know, FastCam was one of the first instruments that we get to try in the Node, and that was very useful. And I will give you a few words. I mean, you heard something from Rosa Clavero the other day. I will give you a few more words about this. And then probably one of the highlights of the partnership between the IAC and Node is this IAC Node support astronomer position. Clearly a story of success. And I mean, today, Rosa is the one in charge of this position. And you know, we need to make sure this is sustained over the time, because it's very useful for the IAC community to get access and to understand the telescope very well, but I think it's also very useful for the Node community to operate the telescope. And you know, Rosa in this case serves as a perfect liaison between the two institutions. So this is I'm not going to go in very much detail about this, but this is clearly a successful story. In fact, the first one is 2014, but yesterday at dinner, Romano Corradi was telling me that in 1996, he was was fulfilling this kind of role, although it was not as official as we did it later on back in the day. In 2020, the structure of the telescope changed, and of course we changed the operations agreement. We upgraded these operation agreements, but this is the last point I wanted to make here in the story, is that it's taken the last 6 years to reach the last, to publish the last 100 papers with the Node, which, look, is not a lot faster than what we did in the past, but in perspective, it's actually what you would expect more or less, given the amount of time that we're given at the telescope. We're given 20%, and you know, this is more or less the amount of papers you would expect also on the minimum you would expect. So I think the collaboration is growing stronger, and it's working quite well so far. So again, perhaps you don't know the IAC community, so let me just give you a few numbers. The IAC has over 200 scientists, mostly based in La Laguna, in Tenerife, but a number of them are also here and are also part of the observatories. And overall, this represents around 25% of the Spanish community, astronomical community. And here you see the evolution over time of staff, postdocs, and PhDs from 1987 all the way to 2021. Right, so it's been a steady increase, more than doubling the number of people since the beginning. Well, way more, actually. Okay, and this is more or less the rate of growth we have at the moment. We typically hire somewhere between 10 and 15 PhD students per year, somewhere between 25 and 30 postdocs, and we're trying hard to hire at least 2 staff members every year. Okay, typically, these are Monica Hall fellows that turn into, go into permanent positions later on. And this is important to sustain the activity at the IAC, because eventually people will start retiring, and we need to be able to sustain all the activities, because we are engaged in many activities. This is the numbers, the overall numbers. If we talk about science, the science program is basically divided in 6 main research lines: formation and evolution of galaxies, exoplanetary systems and solar system, cosmology and astroparticles, solar physics, stellar and interstellar physics, and the Milky Way and the local group. This is one of the latest additions. So these are 6 research lines, and it's all organized in 37 research groups. Okay, there are for this. And all this is heavily supported by Severo Ochoa program that is supporting not just the IAC, but the IAA is also very heavily supported by this to support all our science activities. The IAC is obviously an observational institute in general, although there's a long history about solar physics. There's some theory on solar physics, but recently, in the last decade, thanks to the Severo Ochoa program, we've been able to open new theoretical groups on numerical simulations of galaxy formation, and also more recently astroparticle physics. And this is more or less a pie chart showing you the balance between scientists in the different research lines in the institute. Okay. So now that I'm giving you the rough numbers, what about not specifically? What are the interests of the IC community in NOD? So I'm going to be talking very briefly on some of these things, but it's basically small solar system bodies, exoplanets, massive stars, transient phenomena, supernova, superluminous supernova, deep narrow imaging, and also a bit of optical follow-up of high energy sources. So I'm going to give very brief ideas of what people are doing on these topics, not so much on the last one. But I want you to focus to realize that there's a running theme in this list. I see most people at the IAC are using the telescope for monitoring or follow-up observations on transient systems. Not exclusively, but this is basically the running theme. So getting very quickly into what people are doing, and just putting the names of the people involved up there, so in case this triggers collaborations with you, because they're closer to you. So the work by Julia de Leon and Javier Licandro, together with David Morate, they're looking at near-Earth asteroids, and they're trying to build a survey out of this. And they're spending a lot of time doing photometry, mostly from the Carlos Sanchez telescope in El Teide, but the spectroscopic side comes an important fraction from NOT, GTC, and the INT, all facilities here in La Palma. Their goal here is to characterize the kind of asteroids near Earth, whether they are silicon-based or carbon-based, and so far they have observed around 14 years. And all this is part of different programs, ESA, NASA, and European programs that are involved. Okay. NIAS are not the only thing they're looking at, they're also looking at comets and other kinds of objects in the solar system, but this is the one that connects most closely to NOT. Moving on, there's the work that Hanu, that I believe here in the audience, is doing with exoplanets, and he's interested in transit timing variations studies. I mean, this is usually done with the space-based missions, but not in this case is particularly good because it lets them achieve the same level of precision as these space-based missions, even if it's not the sequence is not as continuous as they would like. But at least they would like to probe at different times this kind of events, and this is useful for them because it allows them to characterize some of the lowest mass planets, exoplanets around. In this process, they also use ALPHOSC quite a bit to get a spectra of the host star and characterize the system completely. And this is typically part of feeder programs, so it doesn't take a lot of time actually to telescope, but it's very useful science. The third case I wanted to discuss was massive OB stars, and I don't want to say a lot about this because Sergio is actually talking in 20 minutes from now. So just they advertise that he spent and he keeps spending quite a lot of time on the IAC spectroscopic database, which is the best effort, very good effort to try to build the most comprehensive stellar library of massive OB stars in the galaxy. And the importance of this is sort of summarized here. You know, it really allows you to touch, studying massive stars allows you to touch many points of stellar evolutions that are very important. And even though this is a multi-facility effort, NOD has played or is playing a very strong part. And I'm going to let Sergio give you all the gory details and about this. Something that came up yesterday, and it was important, and it's not very, and at the IAC we're fairly new about this, is polarimetry. And this is something that Frédéric Potvin and Ismael Pérez Furnon are doing. This is very recent work, where they got some TO time, 10 hours, to look at super luminous supernova, and because they're trying to establish which is the main mechanism that produces them, and magnetar seems to be the best candidate so far, but there are other possibilities. They got polarimetry for 5 superluminous supernovas, and they already published some work. The goal here is to see whether with the polarization they can distinguish between different scenarios, but also different types of supernova. Okay, and again, this is fairly new, fairly recent for us at the IAC, but something that we would like to keep. So keeping polarimetry in the telescope is actually an important thing for us. In this process, it tells me he's been developing his own pipeline. We were talking about pipelines the other day. So if this is something that is interesting to you, get in touch with Frederic, because he will be open to share information on what he's done on this front. And last but not least on this list of topics that I wanted to discuss, something that is closer to me. I work on galaxy evolution. Is the work by Sebastián Comerón with some of the colleagues, where they've been trying to get very deep H-alpha narrowband imaging to look at extraplanar gas outside galaxies. And this is a tough job. This is not something that you cannot do easily with long slits. It's not efficient in the first place. The IFUs around here at the observatory are not large enough to do this in an efficient way. The integration times will be longer. So the only kind of facilities that allows this are telescopes like NOD with beautiful narrowband filters, decent size, intermediate size apertures, and that way you can go really, really deep. Okay, and this is something we should keep, and that's why I was asking the other day about NT, whether the narrowband filters were on the list, because it's also an important part of the IAC community kind of work. So to summarize, if I have to summarize the kind of topics we're interested in at the IAC, this will be the list. So on one side we're interested in high resolution stellar spectroscopy to get radial velocity, stellar parameters, and abundances. Follow-up of space-based observations from different missions. Exoplanets is one topic, but galactic archaeology will be another. Time domain astronomy is becoming more and more popular, and these kind of facilities, bringing a lot of these phenomena, is more and more important to do proper follow-ups and not offer a broad suite of instruments to do that. And again, emphasize a little bit the importance for us for certain topics. The narrowband, deep narrowband imaging. Very briefly, because as I said, Rosa already touched on this the other day, we have one instrument that was mostly developed at the IAC. This is FastCam. This is a lucky imaging instrument. I'm not going to go into details what this is. Of course, know what this is about. But I just wanted to say that it's been tried already on a number of telescopes the IAC has access to, from the Carlos Sanchez in the Observatorio del Teide to NOD, William Herschel, and GTC. They perform quite well, very close to the diffraction limit. But the instrument team, when I talk to them, they tell me that the NOD is actually one of the best places to put this telescope. Something to do with the size of the convection layers above in La Palma, the size of those bubbles, and the size of the telescope. That makes it very efficient. Much more than perhaps a bigger telescope, where you can get better angular resolution, but perhaps at the expense of not being as efficient. So, as Rosa told you, FastCam has been completely upgraded, and when you use CCD cameras, they've been changing quite a bit of the software control software and different interfaces. And while we're trying all this and testing all these new upgrades in the Observatorio del Teide, because it's simply easier, we're really working on ways that we can try to bring it here, because these kind of instruments will be most efficient and most useful here in La Palma with a bigger telescope. Of course, we will make sure that that happens, that this telescope and the NOD community could have access to it. So changing gears a little bit, I wanted to discuss a little bit, things about productivity of NOD and the observatory, to give you some statistics. And the observatory has a wide range of facilities. We have the very big telescopes, we have GTC, we have MAGIC, that they fill the particular, they have some particular purpose, and they're very important for certain reasons. On the other end of the spectrum, we have the smaller telescopes, the 1 meter class, that also had adopted some scheme of operating in a certain way. And in the middle, we have the optical telescopes, the mid-size, that go from 2 to 4.2 meter sizes, that so far have been the more flexible because they've had the most wide range of instrumental possibilities. So how has the IAC used these telescopes, and how has it translated into publications? And these are the numbers in this period between 2016 and 2021. And again, only papers with IAC authors on it. Huh? Make sure this is clear. This is not the broad picture. This is just a very particular picture I'm drawing here. As you can see, the WST is the one with the maximum number of publications in this period, but not is doing quite well, at the level of the TNG, which I think is pretty good. But all of them are producing quite a lot so far. If you look carefully, typically the IAC-led papers are roughly 30% for most of these telescopes, quite substantial. If you allow for second or third author, this number grows over 50%. It does mean that we're pretty interested in the facilities all of these telescopes offer, and not in particular. In terms of fractions, well, this is the fraction. It's the same plot, but just normalized by the total number. So this is basically node contributes for the optical telescopes to the 25% of the publications. To give you a sense of a bigger scale, node produces somewhere between 3 and 4% of the total publications on a given year, IAC. Okay, which is a substantial number. And pretty good if you consider that the best facility, or the most productive facility, put it in this way, at the Roque, which is GTC, is at the level of 10%. Okay? So despite the difference in size, you can clearly see that still people are using it for quite a lot. And then I have another plot because I wanted to kind of normalize this in some way, although it's complicated. I divided up the number of publications by the area telescope. I say, well, let's see what happens here. And careful with this plot, of course. Yeah, node seems to stand up somehow. But there are different messages, and I think there's a good reason for this. I've been discussing at the IAC people with the crowd why do we like not so much. And I'm going to paraphrase Thomas from last night when he said flexibility. And I think this is part of the game. And if there's something I realized this week that I think is pretty obvious, is that node has decided to go into this flexibility, wide range of possibilities mode, as opposed to some other telescopes that they're doing very good science, or perhaps on a much more focused topics. And that, of course, that means that the community you have access to is probably. And I think this is what this thing is reflecting. This is the first message I think this plot is reflecting. The fact that our range of possibilities brings the attention of a lot of the IAC community, and that's why this is so successful here. There's a second message, though, which is very important for all telescopes, in fact. I mean, I was quite pleased to see that there were no big jumps even with the other telescopes. Why? Because that means that small telescopes are still very useful in their own right. You may decide on certain strategies to operate the telescope in the coming years, but the fact that there are no big fluctuations here means that the community, the IAC community in particular, I suppose the general community also, find these telescopes still very useful to do a lot of science. And I think these 3 days we've seen quite a bit of this. I've been quite pleased to see that. And this is definitely one way to go. Just to finish the presentation, how is not fitting into the much bigger, broader picture of the observatory. And this is basically a listing of all the optical infrared telescopes at El Roque and the kind of facilities or opportunities they offer. It's quite broad. I mean, it's really, really nice to have so many telescopes and so many opportunities here. It is obviously an optical observatory in general, okay? Although, the bigger telescopes are clearly putting a lot of emphasis on the near infrared and both imaging and spectroscopy. And then, of course, some of them specialize in the particular things. Their own instruments that, are specific for certain science topics, and this is also a very nice thing to have. If we focus again on the optical telescopes, because what happens? So what I've done here, reduced the table a little bit, and I marked in red facilities that I think that are going to be discontinued in the near future for each of the facilities, in green things that will come up, and in orange instruments that will remain there somehow, or opportunities that will remain there, but perhaps they will be the dominant observing mode for those telescopes in the near future. So if you do this and you clean it a little more, and you stay only with the green black crosses, well, it's not, this is what you end up with. And this comes back to what I was saying earlier, that not the strategy that they've taken is of offering the widest possible range of instrumentation for the community. This is not to say that it's better or worse than the others. Different telescopes take different decisions, and they're equally good because the science topics they're trying to address are very important too. But it's clear to me, at least now, I mean, after seeing this week and after looking at these plots, or looking at the figures that I've been showing you, that NOT has gone the route of being very, going wide range, very flexible in many ways, not only in the instrumentation that they offer, but also in the observing modes they offer. And this is something that is clearly very appealing to the IAC community in particular, and I'm sure that if we were to do the same numbers on the wider community, it would be equally. So just to wrap up, maybe I've been going a bit fast, but let me just end up with a few takeaway messages, okay? I think NOT is a great telescope. There's no doubt about it. Honestly, I've been enjoying this meeting quite a bit. Not knowing NOT, I mean, only heard say, you know, and IAC people say, no, it's a fantastic telescope and so on, but not using it myself. I never had first-hand contact, and I've been quite impressed so far for what I've been hearing this week. I'm going to change the word. It's not flexibility. I'm going to use versatility in this case, but you know, same idea. What you've seen is still doing forefront science, and is complementary to many facilities at the Roca de los Muchachos, which is something that is very strong. Seems to be the most effective telescope for the IAC community. But again, this not to diminish the work of other telescopes, which are also pretty good, and they're doing very well in their own right. This is something, again, I have not insisted, but we definitely need to maintain, which is the IAC NOT Support Astronomer program. This is something that is working well, and we're doing quite well, and we should definitely sustain it over time. And the future is only bright. I mean, I'm really happy about what I heard about NTE, upgrades in FIES, and so on, because it basically, as you've seen in the plot, it will keep enabling a lot of wide-range science. And what I like the most is that all these developments are very much in line with the interests of the IAC community, which effectively means that all the efforts that we've been forging for the last 30 years, it will only become stronger in the next decade. And with that, thank you, everyone.